Hello, Shalini?
Yes, ma'am.
Hello?
Yes, ma'am.
Is my voice clear?
Yes, ma'am. Your voice is clear.
Okay.
Dear participants, the speaker is joining within a few minutes. Okay. Alpa madam.
Yes, Manishbhai.
હા એટલે સાહેબ જોઈન કરે છે અનુરાગ સાહેબ.
Okay, okay,
અમને 2-3 મિનિટ લાગશે કે થોડું સિસ્ટમ જોઈન કરી.
okay.
Uh, Hello.
Hello.
Yes, sir. Is my screen visible?
Yes, sir. Yes, sir. It is visible.
Okay, wonderful. Yeah. So, I don't know whether I am visible or not. Somehow my camera, am I visible?
Sir, your presentation is visible, so your video
Okay.
is automatically off mode.
Okay, I think, I don't know what should I do. Okay, can I start my discussion?
1 minute, please, sir.
Yeah.
Let me
Yeah.
introduce me.
Yeah, sure,
So,
sure, sure, sure.
I am pleased to welcome Dr. Anurag Kandya and all dear participants in the third session of the day. It is my proud and privilege that Dr. Kandya is alumni of this LD College of Engineering. I am Alpa Shah, Assistant Professor of Applied Mechanics Department. And here in this session, we have Dr. Kandya, he is a faculty member in Department of Civil Engineering at PDPU Gandhinagar, and also leading the university's team as a Schedule 1 auditor to Gujarat Pollution Control Board, GPCB. He is actively researching in the area of urban environment and has 3 major and 5 minor projects, which is funded by various agencies. He completed his bachelor's in civil engineering from LD College of Engineering in 1999 and completed his master's from IIT Delhi with dissertation title Environmental Engineering and Management. Dr. Anurag obtained his doctoral degree from IIT Delhi with research on urban microclimate. His areas of research interest are urban microclimate, heat island, building energy modeling, green engineering materials, air quality modeling, green transportation systems, non-power application of nuclear energy for waste management, decentralized solid and wastewater management, wastewater treatment, traditional practices in environmental management, technologies for achieving sustainable development goals. He won many awards like Young Researcher Conference Award and Best Paper Award by International Association by Urban Climate, Young Scientist Conference Support Award by European Association for the Science and Air Pollution, Brightest Youth Climate Leadership Fellowship by the British Council. He is winner of the Summer Innovation Challenge 2018 organized by Government of Gujarat and many more. Dr. Kandya has one design patent to his credit named Roadside Green Shelter Kiosk using bamboo. He has 15 research papers in international journals and 38 research papers in national and international conferences and visited countries like Japan, USA, UK, Egypt, Greece, Ireland, Canada, France, and Singapore for scientific deliberations. I invite Dr. Kandya to share his expertise and knowledge on the subject. I welcome you, sir. Over to you.
Thank you so much, Alpna. I'm extremely happy that I'm a part of this particular short-term training program on recent trends in environmental geotechniques for sustainable development. I thank the organizer, especially Dr. Manish and Sangvi sir, who is my teacher. I remember it's like 21 years ago, Sangvi sir used to be our teacher, and we would be having his sessions. And in fact, many of the professors who used to teach and still are there at LD College of Engineering. So it becomes a very and a matter of great delight for me to be a part of this particular short-term training program. So I hearty thank to all my teachers in front of whom I will be presenting this seminar and this particular lecture, and it's like a circle getting complete. अपनी टीचर्स से पढ़ा था, उनके सामने बड़े हुए, और आज उनका इनविटेशन मुझे मिला और उनके सामने मैं कुछ प्रेजेंटेशन करने की कोशिश कर रहा हूँ. So thank you all, and I would now like to begin my discussion. Um, it's on like when I see this topic, environmental geotechnics for sustainable development. So I catch the important phrase that is sustainable development and how environmental geotechniques can be a part of this particular process. So this is what came to my mind when Manish invited me that I need to have a discussion on in this particular short-term training program. And then I thought that how nice it would be if I put forward, because I'm not a geotechnical engineer core. So I work in many allied areas. So when it comes to me to talk about geotechnical engineering, I catch the word soil. And I thought that I'm working on soil and I'm trying to enrich the soil with some different type of environmental parameters. So I was working on sewage sludge. So I thought that why not to talk about enriching the soil using sewage sludge in this short-term training program, which is having a focus on sustainable development. So that's how the story is. So now I would like to put forward this particular discussion. और इसमें आपको शायद मैं बता दूं कि मेरे पास अभी बहुत सारे answers nahi. It's an ongoing project, and I would put forward the questions which I am trying to investigate. And from this forum, I just have a wish that maybe I would be having an extended collaboration or some input, some guidance, some support. Maybe many of you might be working in some other area which might be having a convergence with the area which I am working. So बहुत सारे सवाल हैं. So I would be presenting a bouquet of questions to you. Maybe this is probably slightly different from the other speakers. They might be having many answers. I'm having few. So the few answers which I had, that I'll be discussing, which will be putting forward to all of you, and the questions which I'm trying to investigate. And maybe after my questions, I would be very happy if I can have a discussion with you in this session itself. So going ahead with this, now this is something which we all are aware of. We talk about the growing population. In 1990, we were 5.3 billion, and we expect that maybe 2100 we would be 11.2 billion. So when we talk about this growing population and then we have many problems related to that, what comes to my mind is that we should be looking back to what are the norms of the ideal ecosystem which puts the foundation for sustainable development. So here,
sir, can you please make slideshow?
sorry?
Sir, can you please make slideshow, sir?
Yeah, this is slideshow only.
No, sir, it's
because I am putting on from current slide. So if I put a current slide, I'm having this. Are you able to see the presentation?
before actually your only first slide was only visible.
Okay.
Your second slide was not visible to participants.
Okay, so I'm now right now is my first slide. Now I'm switching on to second. Can you see my second slide now? No.
No, sir. This is third one presently which you have shared. That is third one.
Because that's how we share.
Yes, now it's second, sir. Now it's second slide.
I think there is a lag.
Oh, yeah. There may be possibility. Yes, sir.
Yes, there is a lag. I'm okay. So what I'll do, I'll read out the slide number and then till you say it is visible, I'll not discuss. Right? That's how I'll go. Because पता नहीं चलेगा मुझे कि slide बदला या नहीं बदला.
Okay.
तो अभी कौन सा slide दिख रहा है आपको?
First slide, sir. First slide. You're enriching the soil using sewage sludge. Main title वाला slide है.
ठीक है. That is all. Now I have changed. Okay, what I'll do is, uh, can you see the slide, second slide now?
Yes, yes. Now it's clearly visible.
Okay. So what I have to do is, I have to, for every slide, I would go and put it for slideshow. That is how it will come. Because sometimes in the other lecture also this problems comes. The routine slideshow doesn't work. I have to individually go for the slide and then that slide comes.
Yes, yes,
So
yes.
I'll do that way. Yeah,
Oh,
thanks
oh,
for telling me. Yeah, okay. Yeah, sure.
thank you.
Okay, so this is what we see, the growing population from 1990. We talk about 2011, and we say that it's going to be 11.2 billion. So what I thought that to have the basic definition of development. So if I just put this development, the present model of development, we many times think that economy and environment may not be going hand in hand, and what we see is like the type of advancement which we are making, we are trying to risk our own life, and many of the observations I think are clearly visible to all of us, that what mode of development are we following and what are the aftermaths. Manish, this is the third slide, right? So I hope it is seen, present model of development.
Yes, sir.
Great. So I now would begin with quickly, uh, how do we define the basics of sustainable development, linking it with ideal ecosystem, and from there I'll pick up how sewage sludge, organic farming, enriching the soil, and the type of research we are trying to pursue in this domain. Now, if we see ideal ecosystem, this is what we studied in our first year engineering. And maybe these topics, these definitions and these keywords are still so relevant, and we are missing out that we are not able to incorporate these things in our system. We talk about the population of any species is limited to the available resources. Probably we might be violating on that. The species diversity is adequate for efficient recycling, and we understand that the species count is declining day by day. Third point, which talks about the population load not to exceed the self-purification capacity. And I think we have exceeded the population loads to that level that there is nothing like self-purification capacity left to the system. We talk about energy consumption of the system to be minimized, and somehow if we see the share of renewable energy sources till date, we have only 28% coming from that, rest 72% is still coming from the fossil fuel. And finally, if we talk about the system to be capable of continuing indefinitely without heading towards a dead end, which is actually a question mark whether we would be going towards infinity or not. So what I'll do is, we are trying to gauge the present system and then link it up that how are we going to achieve the sustainable development goals and the way ahead. So there are few big questions which I'm wanting to put forward. The first big question is the population. Now, if we see the current rate at which our consumption is going on, by 2050, it is anticipated that we would be requiring Earth's resources equal to 3 Earths. So we need to really question that is our cycle of material um, utilization, material conservation, and material recycling effective enough or not. We talk about water, very important because I'm going to connect it to agriculture and soil. Now, if you see this big picture, we have by 2050, India will have 22% of the present daily per capita water and 70% of drop in the water availability in the last 60 years. So that actually becomes a question that how much are we mismanaging this very important resource. So that's a question which we need to understand, because agriculture is consuming 80% of the total water which we require. The third big question which we talk about is the species diversity. Now, we all are aware, those who are from Ahmedabad, they would be very much aware of piranha and the other land dumping sites. We have also started opting for ocean dumping. And if we talk about these two dumping, it is a clear indication that there is a drift from a circular economy to a linear economy. That means take, make, and waste. And that waste is coming out is as an ocean dumping or piranha or piranhas. So we need to see that how can we, put that circular thing and make our cycles little more stronger if we need to talk about sustainable development. The third and the next question is population loads. Now you talk about water, wastewater. This is one of the this is the discussion which I will be having in next 5 minutes. What is the quality of water? What is the quality of wastewater? What is the quality of soil? What type of food are we eating? So if we talk about sewage, now if we see here, we say that 75 to 80% of the water pollution is caused by domestic sewage. And what is happening? Only 30% of this domestic.
Sir, sorry to interrupt you. Once
Yes.
again, the slides are not moving.
Oh my God.
It is on 5th slide, sir.
Population. Okay. Actually, it is animated, so I don't know.
Sir, can you press F5?
This is actually F5 only.
But presently, sir, it is not full slide show, sir.
Okay, what I'll do is there is a different way of uploading the presentation in Teams. Let me. Should I try that?
Okay, sir.
Let me see if I'm able to do that. I'll unshare right now.
Sir, no issue. You continue.
And in sharing, I'll try to upload in the drive
Okay. Okay.
from my computer. If that works out, probably it might be slightly better. यहाँ पे तो ऐसा नहीं आ रहा है.
Sir, you may reshare. I think it will start working, sir.
Okay, I'll do that. I don't know whether you're seeing the slide.
Yes, sir. Slides are visible, but it is not under the slideshow mode. Sir, it will be okay if you continue with this
Sir, you
only.
can continue, sir. You can continue, no issue.
Okay, so what slide are you seeing right now?
Number 2.
Okay, now I. So, okay. Will it be, are you seeing the slides now? I'm just changing it. Like now I'm showing you ideal ecosystem.
Presently, sir, it is number 2, sir. You can, now it's 3.
Okay.
I think no, it's 5th, sir. 5th.
Now, yeah, fourth. Yeah, now I'm showing
It's
you
fourth one,
fourth.
sir.
Now it is so now it is not in the slideshow mode. It is just I have opened the presentation and
Yes, sir, but it's perfectly visible, sir. You can go ahead.
okay. So I'll slightly enlarge the size. Okay, let me see if only thing is the animations will miss out because I've covered few things in like
No, no issue, sir, because all the text matter as well as the pics are
ah
clearly visible, sir.
sure, that's nice. So okay. By any chance, if you're seeing this, because it
Eighth
is like
number slide.
yeah. So I'm just talking about the pollution loads. And I'm putting it like the domestic sewage, which is around 75 to 80% of the total water pollution. In that, we are just treating only 30% and rest is untreated. So this is the status of the domestic sewage, and we now need to think about that how we can harness this domestic sewage along with the sludge if we can do something for the agricultural productivity. So this is the thing. Now I'll try to switch on to the exact because I have missed out. So in a nutshell, if to the benefit of the participants, in a nutshell, what I was trying to say in the previous slides, to gauge the present scenario and to figure out whether this model of development can sustain infinitely. And on my screen, I was trying to put forward a infinity symbol because we need to talk about can we move towards infinity. So now I'm moving down to 11th slide, wherein I have mentioned Agenda 2030 Sustainable Development Goals. Is this slide seen?
Yes, sir.
Yes.
ओके ओके ओ आई वाज सो मच स्ट्रेस्ड मेरे स्लाइड नहीं दिख रहा है तो मुझे बड़ा अफसोस हो रहा था आई होप नाउ इट इज सीन दैट्स नाइस
Yes, sir, it is visible now.
great so here I now looking forward that these are the 17 goals which we need to think and answer a question, can a city be sustainable? From that agenda for today's discussion, what I have picked up is good health. And good health, I'm trying to link good food, good health, good life. And for good food is something which we need to talk and discuss. That how are we going to get a good food? Now, slide number 13, wherein I am trying to put forward the entire aspect of agriculture in terms of employment and GDP. Now, if you see from 1991 to 2018, the share of employment in terms of agriculture that might have been declining, but as on date, still it is the largest share of employment holder. So for around 44% of the the employment still is coming from the agricultural sector, though it might be around 15% of the GDP in the share. So we need to really talk about that how we need to strengthen the agriculture, and the civil engineers have an important role to play because we are trying to put forward what is called as soil water interaction. Now, the next important thing, as what I mentioned, I have two things. One, if you're able to see my cursor, one is I am focusing on soil, and the other I am focusing on the water, and then the interaction of these two, that is soil water interaction, we see it in terms of agriculture. So there are many other factors which are responsible for the improvement or the degradation of the agriculture, but soil and water definitely play an important role in in the entire agricultural aspects. Now there are few animations, like few things which I wanted to animate and put forward for a better impact. So I don't know, I'm just trying to see whether these animations are seen or not, because it is on a sequence of thoughts which I have put up. The first thing, the soil organic carbon content. Now, Indian soils, if we see, the organic carbon content is 0.3 to 0.4, which is well below the acceptable limit of 1 to 1.5%. That means the first important thing which we need to figure out is, can we increase the carbon content in the soil? The second important thing which we should be registering, that the human waste is having 40 to 50% of carbon, maybe of different type. The fixed carbon, that is organic carbon. So there are different type of carbons, followed by nitrogen, phosphorus, and potassium. Very importantly, we should understand that if this is not managed properly, and if it is actually being sent to landfills, and we have a landfill in Ahmedabad itself, that contributes to a lot of greenhouse gas emission along with the water contamination. As per to the US EPA document, landfills are the world's third largest anthropogenic emission source, accounting for 12% of the global methane emission. And lastly, it has been outlined that agricultural soil have been identified as a significant potential to sequester soil organic carbon, thereby mitigating the climate change. Now, if this carbon, which is going in the atmosphere, if it actually does not go to the atmosphere and comes to the soil, we would have two aspects. One, we would mitigate the climate change, and secondly, we would improve the soil conditioning. So it's like one strategy and two gains. But having said that, it's really, when it comes down to ground, we have enough challenges to actually address. So here comes, I'm now going ahead, keeping in background the sustainable development goals. The slide which I'm trying to put forward is, proper treatment and management of the human waste can increase the soil organic carbon content and sequester go for carbon sequestration, which will mitigate the carbon-led climate change. So this is the background, the bigger background of the entire research. And currently you can register this. As far as the humanure is concerned, we currently don't have any standards. So the project which I'm working with Department of Atomic Energy, funded by a Board of Research in Nuclear Sciences, is towards having some standardization for humanure and what type of treatment has to be given so that they can be used safely. So if I say, Manish, I'm on the next slide. It is
Yes,
seen.
sir. Yes.
Wonderful. If you see the agriculture, as I said, 80% of the water we are using in the agriculture. And on the other side, we have a dwindling state of the availability of the water. And if it goes below 1000 meter cube per capita per year, then we are declared as scarce states. Around 38 billion liters of sewage is produced daily. You talk about Ahmedabad, we have 950 million liters of sewage produced daily. And presently, if we see, the sewage farming is practiced. Now, we need to now find out treated, untreated sewage farming, treated, untreated sludge, how they are impacting the agricultural aspects. So if we are able to do something on that, then we would be having two things. One, moving towards water security, and second, boosting the agricultural productivity. So this is what, the bigger agendas which we are having from this particular research, right? So now moving ahead to what is called as organic farming. Now, when I was trying to discover, to quantify or to actually articulate organic farming, what I could see is, because this is what the definition which is acceptable, I mean, which has been told and outlined, that we are using biological materials and avoiding synthetic substances. So we are not using pesticides, we are not using insecticides. So anything synthetic we are avoiding, everything we are using biological, and that is constituting to the concept of organic farming. We might be having more definition, but this is something which is actually going on in the fundamentals of organic farming. And what we need to see, as what I told you earlier, water quality. So when we go for treated sewage, what happens to the soil and what happens to the agriculture when we are using untreated sewage? Directly, if we are going for sewage farming, what happens to the soil and what happens to the agriculture productivity? So this is what. Secondly, if we are using treated sludge, now treated sludge is something which is still a distant reality. So, and next, there's a mistake. Instead of untreated, I have written treated. So there are two things: untreated sewage or unhygienized sewage, and hygienized sewage. So this is what we need to talk about in terms of water quality and soil quality. Now, this is the flow diagram. Probably I want all of you to have a more, a close interface, because this is what we are trying to deliberate in our research project. We start with human consumption. If by chance, if you're able to see my cursor, we have human consumption. We have the sewage which is generated. This is domestic sewage. Now, domestic sewage, can I use it directly? That's one. It is sent to a sewage treatment plant. Now, I have, if you see Ahmedabad itself, there are three types of concepts which are used for treating the sewage. So different type of technologies. So my focus is what type of sewage is getting into what type of treatment technologies, and they are resulting into what type of outputs, both in terms of treated sewage and in terms of sludge. Now, in a sewage treatment plant itself, we are having primary sedimentation tank, secondary sedimentation tank. So wherever we are getting sludge, at whatever stage, we are trying to collect that sludge and trying to go for a characterization of that. So that is one. So from a sewage treatment plant, we are getting different type of sludge, which if you see here, so that can be used. Now that, if this arrow you are able to see, can I directly use this in the organic farming? And suppose you say that I can still improvise, can I go for hygienization? Many researchers have actually pointed out that hygienization would be changing the physical and chemical characteristics of the sludge. What changes are happening is what we need to document and understand. So this is one aspect which we are trying to deliberate, that what type of hygienization. Gamma radiation is one type of hygienization which we are trying to attempt, and we are also attempting sun drying in other processes, and finally coming down to this bigger question of how we strengthen organic farming. So we have four ways, four type of inputs, as I told you: untreated sewage, treated sewage, untreated sludge, and treated sludge, all towards improving the agricultural productivity. Now, I would like to put forward some basic findings, so that, my purpose is to bring forth the small study which we have done, focusing sludge and sewage. Now, in this small case, where we had gone to 6 villages across in and around Ahmedabad, we investigated 60 farmers and 60 farms where different type of sewage and sludge were used. Most of the time we got the utilization of sewage, and sludge was still, we are again investigating the responses where there are evidences that the sludge is getting utilized. So these 6 villages where we
So,
carried out.
sorry to interrupt you.
Yes, yes. Again, the slides are not seen, right?
So,
Yes.
sorry to interrupt you. Actually, slides. Yeah, it's So the slide right now it's 16 number slide.
Okay, 16 number slide. Okay, so now I'm putting on 17.
Yes, sir.
Okay, so I
Organic
discussed
farming,
on,
yes.
yeah, I discussed something on like basic definition of organic farming because we talk about soil and sewage soil. So I discuss organic farming. This is slide number 18 where I put forward water quality and soil quality as a matter of investigation. So we were trying
Yes,
to
sir.
investigate how the water quality and soil quality are impacting the entire agricultural productivity. Okay, now, okay, this, if we have missed out seeing this slide, slide number 19, is the slide number 19 currently seen?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, I think this was not seen previously, right?
Yes, sir. Earlier it was not seen. Now it is
Okay,
visible.
okay, so this is a very important slide. In fact, the entire research project which I am having, revolves around this particular slide. So it starts, if you're able to see my cursor, it starts with human consumption. Then we have after the human consumption, we have the generation of the domestic sewage. From this domestic sewage, one may go for, can we use this domestic sewage directly? That's one point. Then if that is not a valid option, then I go for a sewage treatment plant. Now, as I told you earlier, in Ahmedabad itself, there are 3 types of sewage treatment plants using different concepts. So, what type of sewage is getting treated to what level and what is the output in terms of sludge by these 3 different type of sewage treatment plant is again a matter of our investigation. So this is what I was trying to put forward, that this domestic sewage is going on into the sewage treatment plant and we have different type of sewage treatment plants. That is one. Secondly, each sewage treatment plant will be having different stages at which we can actually get the sludge. Primary sedimentation tank, if we talk about, you'll get one type of sludge. Secondary sedimentation tank, you will get another type of sludge. So primary, secondary sludge we are trying to characterize and find out that what are the different type of ingredients, how things are changing, whether it is getting enriched or we have to do some changes. So that is a matter of investigation at this level. So from here, we have 4 outlets. One is like you talk about the sewage sludge at different levels. Now this we can directly use for organic farming as what is actually happening currently. Can we improvise this is what we are trying to see by the matter of hygienization. Now this word hygienization has in the last 1 year has got has increased in its importance many folds. We talk about sanitization and the bigger word is hygienization. So whether we hygienize our sewage sludge and use it, and whether that would be having a good response to the agricultural productivity is a matter of a very big question. So this is what we are trying to investigate, that if we are going for different dosage of hygienization from this gamma radiation, how much, what would be the impact on the germination index of a soil which is having sewage sludge. And that also we are having 6 types. So each technology, 2 types of sludge, we have 6 types of sludge. In fact, few we are also having tertiary. So we are having different type of combinations and how they would be responding is what we are actually looking into. Now I'm going to slide number 20. Is slide number 20 seen?
Yes, sir.
Yes, sir.
Right. In that, the focus is assessing the impact of utilizing the sewage or sewage sludge in farming. Now, this is a small study which we have done with 54 villages around, wherein we talked about six like in the present study we are considering the outputs of 6 villages. 54 villages are what are using the industrial wastewater, treated and untreated domestic sewage. So, what are the responses? What forms as a basis for utilizing this for the agricultural productivity? So, if you see here, now I'm seeing the next slide, that is slide number 21, wherein we say, is it seen?
Yes.
Right. So, the field surveys in the 6 villages wherein we carried out for 5 crops: wheat, groundnut, castor, cotton, and rice. Now, you would be happy to see the results. Now, these are the raw results which we have directly got from the farmers. Of course, I have reasons to like, he had told with his observations and understanding. Now, prima facie, we believe that whatever he has told is correct. Additionally, we are trying to use a satellite data to talk about the NDVI, wherein we get some idea regarding the vegetation. If they correlate, then probably we will have more confidence in agreeing to the results. So what was responded by 1 to 7 number farmer who were using groundwater and using the domestic treated domestic sewage. So initially they were using the groundwater, so they had some productivity values, and then they started using treated domestic sewage. Now I'll again make you clear, in this treated domestic sewage, what was used was a primary sedimentation tank only. And what they observed is what is the level of increase in the productivity. So all from the 7 farmers, we got the response that 6 cases that there was a slight increase, like the inference was that the productivity increased. Places where untreated sewage, that means directly without any treatment, the sewage was disposed along with the industrial wastewater, in all the cases the productivity was decreased. This is one on-field observation which we got uh, to understand that what is the impact. Also qualitatively we had an estimation that productivity kaise change hoga. Now we had some figures also to talk about that productivity has changed, the increase of 23% and a reduction of 43% for wheat. Similarly, we had done this for all the different type of crops, and we see that this is how the productivity was impacting. That means one good observations which we can take on hand, that treated domestic sewage is in a way improving the productivity of increasing the agricultural productivity, which give us confidence that if we are also nourishing the soil with treated domestic sewage sludge, we might be getting increase in the agricultural productivity. So this is one gross observation which was documented. Secondly, we wanted to understand what is the quality, like if you see the type, I'm on slide number 24. Is this seen?
Yes, it is visible.
Yeah. Slide number 24, if you see, assessing the quality of different types of irrigation water and soil. So the type of water which I am using, and after the soil water interaction, what is that which is getting retained in the soil. So this is what the agenda was. So we had 4 parameters. If you see, normally we talk about NPK and carbon. So we actually analyzed NPK and carbon. So here if you see nutrients, in the category of nutrients, the type of irrigation water. So in the first case I was using like it was the untreated domestic sewage along with industrial wastewater. TOC was very high. Then if you see the next, that is treated domestic sewage, the TOC was less, and groundwater, which was used in an organic farm, the TOC was very less. So this is one observation. If you see nitrogen, potassium and phosphorus, the results are in front of you, right? On the same samples, we try to analyze the we analyze the soil characteristics. So we got that in spite that the domestic sewage, if you see my cursor, the TOC was less in the domestic sewage, but when we analyze the soil there, the carbon content was high, which was coming as more than 1%. Our target is to reach to 1.5%, and that is what is ideal. So that gives one evidence that mixing of the industrial wastewater, though the TOC might be high, but the retention of this is getting is comparatively less. If you see the organic farm, there the TOC was less, and what was retained also was less. Again, this observation gives us evidence that if we are treating the domestic sewage, then the retention which is happening is slightly better. So the carbon content, similarly, if you see the nitrogen, potassium and phosphorus, there are some observations which I have concluded in the as a final outcome. So that was NPK and carbon. We had done some heavy metal analysis also. So what is the heavy metal contamination? So we have just restricted right now for 5. In fact, for soil we could do only 4, and then we had we had to stop, and now again we are resuming back for the extensive characterization of the different type of soils. But here again the observation was that in terms of retention, we had few different like what is the content which is present in the water and what is actually getting retained in the soil and to be made available to the plants. So that is what in observations. If you see the okay, that slide is missing. So what we could find out that basic treatment of the domestic sewage is actually helping in the retention in spite the concentration being low on the influent water. So this was one observation for sewage. Now the next target was we need to estimate the quantity of sludge from the respective sewage. What type of sewage and what is the type of sludge, and then characterizing sewage and sludge both together so that we understand basically what the impact of the treatment technology on the sewage and the sludge. Finally, we need to see the entire wastewater treatment process as a factory to produce sludge which can be actually profitably used for enriching the soil. So this is what we talk about. Now if you see here, characterizing of the unhygienized and hygienized sewage sludge. Right now I am just putting forward unhygienized sewage sludge because the radiation plant is currently out of, like, we are not able to reach out to the hygienized sewage sludge samples. The moment we are able to get those hygienized sewage sludge samples, we would be adding on to our analysis. Now the focus, the focus was to find out what is the impact of this hygienization on the physical, chemical and biological properties of the sludge. So as a case reference, we have taken 2 units. One is of our university. So we have a 500 KLD plant, and one we have taken it from the municipal corporation, which is of 240 million liters per day. So one small level, that is 500 kiloliters per day, and other is 240 million liters per day. The results are currently for of PDPU campus. Now here we worked out like estimating what is the solid concentration, and from there we worked out that is typically what we could retain in the as a sludge is 554 milligrams per liter. Given the variation, so there are some maximum and minimum which we can see, but typically if we work out on an average, this is what is the estimation. so on the same lines, if we see, if we plan it for our city, so this is the total quantity of the wastewater which was coming to the PDPU wastewater treatment plant. So we got an approximation, and having an estimation that based on the previous experiments, we could work out that approximately in our campus we are having 133 kilograms per day as the dry sludge. Now, if I extrapolate this, assuming that the sewage treatment plants of the city are functioning and to a respective level, then typically 527 tons per day is the dry sewage sludge which I can actually generate. Now, if I still, assume that maybe it's the operating conditions are like that, that around 50 to 60% also it is operating, still I would be having something around 300 tons per day as the dry sewage sludge, which can be used profitably as a conditioner. Now, very importantly, you should be seeing this table. That is the two things we have analyzed. One is the type of sewage and then the corresponding sewage sludge. Why this is important? Because we should be in a position to quickly tell what would be the type of sludge which we would be generating from this particular technology given these operating conditions. Now here, from an approximation, we can see that your sewage sludge might be having a variation of 178 to 450 milligrams per liter, but the sludge variation, if you see, the content is around 11 to 19 milligrams, like 11 to 19%. This is what is the variation which we could see. Average, if we are able to work out, typically 15% is the carbon content, 0.8 is the nitrogen content, 0.06 is the potassium content, and 2.5 is the phosphorus content. What we observed is when we are analyzing sewage sludge, it's the potassium content which is coming on the deficit side. Rest of the parameters are acceptable. That means the sludge which we are getting, if we need to enrich it, few specific measures can be done. Now, this is our initial observations regarding the sewage sludge from a specific type of treatment technology. So, this was our initial finding, and what I said, the way ahead which we are planning to assess the impact of the wastewater treatment technology along with the operating conditions on the quality and quantity of sludge. Now, this is a very big question. Day by day, we are having innovations in the wastewater treatment technology. Now, how they are going to change the quantity and quality of sludge. Additionally, we can add quantity and quality of sewage. I want my sewage to be better, which means my sludge would be enriched. Now, here I need to see that what type of contaminants from the industry which are coming up. My previous observations clearly reveals the places where the industrial wastewater is getting mixed with the domestic sewage. There, if we are using that type of water, the productivity is actually reducing. So this is one specific observation. Secondly, what we are trying to figure out, and this I'm just giving it as a matter of thought to all the participants to actually have a thought on this, that how are, like, what is the impact of hygienization, and I have specially mentioned gamma radiation because this is one technology which was suggested that we can achieve a complete sterilization of the pathogens. Now, after complete sterilization of the pathogens and introducing good microorganisms which are actually improving the fertility of the soil. So overall, how this would be taken into, like how the sterilized sewage will be responded by the microorganisms which we would be introducing, how the organic carbon inorganic carbon, soluble carbon, inorganic, like insoluble carbon, ammonical nitrogen, organic nitrogen, and many other nitrogens, which like many more compositions which we are trying, how they would be impacted by the process of hybridization. So the third objective which we are investigating is to study the response of the different sludge along with the respective treatment on the germination index. So we may not be going into the core as a botanist or as an agricultural scientist, but to a level of that, how are we going to, what is the impact of this particular type of sludge on the germination of this particular seed. And more importantly, a very big and a standing question, can we evolve mechanisms for thickening the sludge? So dewatering, bed pressing is what is actually, filter pressing is what is actually happening. And in that, what has been observed is we are additionally creating sewage because of this bed pressing. So can we actually thicken the sludge in a different manner that the nutrients remain in the sludge and some less a better quality of uh, water comes out comparatively. So that would be making the sludge more richer. So these are the still more questions which we need to investigate. So finally, if I put it as a matter of question, that is sustainable development a myth? So it's like it's not going economy and environment. They are not on locking horns with each other. Probably it's the scientific intervention which might be giving us more options for going ahead in sustainable manner. So this is what I personally feel, that we can fly high, so we don't know how much we can go up, so we need to explore more options, and if we are opening up more options, probably these technological interventions will be infusing new concepts of sustainability, and with this new knowledge we might be coming closer to what we define as sustainable development, the classic definition which says that meeting the demands of the present generation and not compromising the demands of the future generations. So I am open for questions, discussions, deliberations, and I look because I have less results and more questions. Those questions which are still not solved. So that's how I present. Manish.
Yeah, thank you, sir. Thank you very much for your very informative and deep insighted presentation on the sewage and its uses. There are some few questions by our participants.
Great. I would
First,
be happy to take them.
yes, sir. The first question is by Preeti Mishra. The question is, will the heavy metal retention in the soil be harmful to the crops and ultimately to the whole food chain?
Definitely, yes. Now, this is what, in fact, in the genesis of this project, we had initially planned that the moment we are having this industrial wastewater getting mixed with the domestic sewage, do we plan for a specific absorption of the heavy metals? I was suggested that, why don't we try something called as grafting of the polymers, and then a specific retention of these heavy metals so that they don't enter in the food chain. So yes, heavy metal retention in the food chain uh, would be, and that's what we have seen. Places where heavy metals were, like when we talk about industrial wastewater, so we did not analyze the industrial wastewater and domestic wastewater because that was a historic. तो बस उनके फार्मर्स का जब ओपिनियन या ऑब्जर्वेशंस लिया, तो all of them, systematically for all the 5 crops, they had revealed that the productivity was going down. So that means prima facie we can say that when we are going ahead with this heavy metals, then it is definitely impacting the agricultural productivity. I hope I answered Preeti's question.
Okay. Yes, sir. Yes.
Anurag,
Another question.
can I? Okay, sorry, Manish bhai.
Yes, yes, Poonam madam, please carry on.
Yeah. Uh, so first of all, doctor, I would say a very, very interesting lecture, something, much different from the current lectures. And so that's why, I mean, it was quite appealing. So my
Yeah,
question, yes, sir.
yeah, yeah. I was going through the list of the topics, and I really found कि मेरा मेरा ना ये थोड़ा अलग है, क्योंकि I was not talking about lining. I was not talking about the landslides. So when you talk about geotechnical engineering, probably ये बहुत important domains हैं. But when I talk about environmental, जो मुझे लगा कि मुझे थोड़ा एक सॉइल को एक
Definitely,
डिफरेंट
definitely.
पर्सपेक्टिव देना
Yes,
चाहिए
and
इसी.
so your lecture was such a like a refreshing break, जिसको कहते हैं ना, because especially with people who are not very much into the geotechnical engineering, then this was truly a boon. And so secondly, your mode of delivery, awesome. I mean, one can just keep on hearing you for hours. So that is why
I'm
probably we
glad.
were, so glued. Okay, now sir, asking
Yes.
about my question, probably it might sound very, very novice, but as I was just hearing to your presentation, I was just pondering over that how this treated domestic waste or sludge can reach to the farms. I mean, what exactly would be the mode of transportation? Because
Yeah,
when
that's,
yeah,
see, as I told you, I was, just imagine that this wastewater treatment plant is a factory of producing sewage. I mean, a factory of producing sludge. Now, we put it this way. Now, when you talk about a factory, we have few ingredients coming in the system. So we have many chambers, तो उसमें एक से unit में दूसरे में जाता है, and then finally we have a product. Now here we are taking the sewage sludge as a product. Now the moisture content is high, so that's again a hindrance. And secondly, if we are able to reduce the moisture content, so there are many technologies, and currently Ahmedabad Municipal Corporation is going for this filter pressing, bed pressing, and reducing the moisture content. And after reducing this moisture content, it is actually supposed to be packed like we have the normal, if you see the organic manure which are available in packets. So either it can be packed, or as what they are planning, that truck bhar ke we would be going ahead in the farms, and then as per to the requirement we would be going for enriching of the soil. So this is what, like, two way, like if we are able to have this product to that level after getting all the clearances and all the hygienization thing, then this actually becomes available in the market. But additionally, I would like to make that it is not that कि sewage sludge use नहीं हो रहा, definitely हो रहा है,
yeah,
but treated wala, like after hygienization, that is yet to come, because we need to compare two things. What if I'm hygienizing, and what if I'm not hygienizing? I mean, if I get an advantage कि अगर मेरा productivity बढ़ता है, या मुझे और कोई pest control नहीं करना पड़ता है, या मेरे fungal attacks कम हो जाते हैं, then I have reasons to actually go ahead that we need to hygienize it and then use it. So that comparative analysis is still not done in our country, and I must say this project which I'm handling would be first of its kind to have the results on this direction. Second, a plant which is coming in India from Baba Atomic Research Center is in Indore. तो अभी जो ऑपरेशनल लेवल पे है, दैट इज फर्स्ट इन इंडिया, दैट इज अहमदाबाद. तो उसका ही अभी आउटपुट अभी हम लोग कर रहे हैं. बट या दैट इज हाउ आई वाज ट्राइंग टू आंसर योर क्वेश्चन, जो आपने पूछा कि ये प्रोडक्ट अवेलेबल कैसे होगा.
yeah,
So this is like you are having either it will be packed, or suppose the quantum is big enough and there is a big demand. The second important question is the shelf life. Now we have yet not investigated, and it is still a question, that what would be the shelf life of the this sludge. the domestic sewage sludge, उसमें fungal attack या any other attack, bacterial attack or any pathogenic attack वापस कब तक नहीं आएगा? You know, you have a hygienized process, but that hygienization might be staying for next 15 days, and if it is coming back, that is again a matter of question which is still unanswered.
Okay, okay, yeah. Thank you very much, sir. So actually on those lines, but since you have already mentioned that it is quite in a rudimentary stage, because my very next question was that only, that have you presented this to any policymakers, and like how much are they, I mean, they have shown the readiness to take it. And you know, sir, while listening to this concept, I do not know, I just had this faint idea in my mind that this big townships which are now coming up, so let's say in that township itself, if there would be some miniature you know, this kind of a thing which could treat the domestic waste, and then the same water or waste can be used for the landscaping or gardening purpose of that township. I really do not know, I mean, can we look forward to something like this in the future?
Definitely, we have no other option but to actually go ahead for this only, because we talk about consumption of water now, per capita availability of water is coming down. So if we don't go for toilet to tap, then we may not be having options. So those small townships which are coming up, in not only township, we talk about, let's say, PDPU campus itself. Now we have a sewage treatment plant. So we not only we are trying to utilize the entire sewage which we are treating, and so uska bhi we have to see the quality and how far it is going to improve the productivity. So that is one of the agenda. And the second is the sludge which is getting generated. Currently, we are not using, see, PDPU campus is not using the sewage sludge. So that becomes a question for us to investigate, that iska characterization karke, iska nutrient value along with the pathogenic stability. If that is done, then we say that we can actually sell it in the market, that okay, this is what is available. If the estimations are to be believed, what we have done in PDPU and what observations which we have got from Ahmedabad Municipal Corporation, typically we talk about around, if everything is fine, then it's something around 500 tons per day. Even if the calculations are wrong, on a lower side, if I go for an empirical observation, that turns out to be around 300 tons per day, taking an assumption that per person the dry mass sewage is around 10 to 15 kilograms per year. So if that approximations even I consider, then also I'm landing up to 300 tons per day. Now 300 tons per day organic manure which is available, and that becomes very important. And here we have to note a very important point which was made by our Honorable Prime Minister. We have to reduce the dependence on chemical fertilizers. Very strong point which he has mentioned, that we have to reduce the dependence of chemical fertilizer. Now, if I have to agree on this point, then I have to work out that this nutrient rich product which is available, which we are currently not utilizing the way we should have done it, that is to be seen very critically. So ये जो आपने बात कही कि we have to use the treated sewage, yes, we have no other option actually but not to use this treated sewage. So we have to do this, and additionally we have to use the sludge also. So these are the two important things which we, and that is how the cycle gets complete. Otherwise, if we are taking, making and wasting, so we have piranha. So we have piranha, then we have a lot of other problems, be it health, be it, so, you know, so that entire linear thing has to be circularized.
Right. Thank you very much,
Yes.
sir.
Thank you, sir. Sir, one more question from participant, that if the sludge has to be used in agriculture, what should be the standard guidelines, and with what comparison has to be made, with whom?
Yes, so that's one fundamental question. Humanure, like the sewage sludge, the domestic sewage sludge currently is having no guidelines, and guidelines have to be made for it. So a very important thing I think I have mentioned it in my presentation also. Currently, we are not having any guidelines. We are having guidelines for organic compost, which we are getting from our kitchen waste. But we are not having guidelines when we are using the domestic sewage sludge. So those guidelines have to be formed. See, it can be understood that way. Some 30 years back, probably we may not have thought about that this could have been so big a problem. So, but now if you see, we have a huge quantity of wastewater and huge quantity of sludge, in spite that we are just managing 30% of wastewater. रेस्ट 70% तो हम ट्रीट ही नहीं कर रहे हैं, तो उस 70% का तो स्लज बनने का भी सवाल नहीं है. बट अगर ये गाइडलाइन आता है और इससे एग्रीकल्चरल प्रोडक्टिविटी के लिए देयर इज अ क्लियर कट बेनिफिट, देन आई थिंक इट्स माय एंटिसिपेशन that once we are able to generate something which is improvising the agricultural productivity, ये जो बाकी का जो 70% वेस्ट वाटर जो हम ट्रीट नहीं कर रहे हैं वो शायद ट्रीट करने लगेंगे. So currently the answer for this respective question is we are having no guidelines as on date.
Sir, one more question.
Yes.
That when you are comparing the domestic sludge and the industrial sludge, no doubt it will move on the type of industry and its processes and another thing.
Yes.
But as far as the soil retentivity is concerned, that is the mineral retention is concerned, is there any observation you have made with respect to these two type of sludges?
Yeah, see, that is what I had told earlier, that what we observed. Now, the question which in this question, what is mentioned is that what type of industrial waste. So that is not, we could not analyze, because what we had observed at the first level is places where industrial wastewater along with domestic sewage जो जहाँ use हो रहा था. So ये किस इंडस्ट्री का आया है वो हमको नहीं मालूम था. इंडस्ट्रियल सीवेज डोमेस्टिक सीवेज मिक्स होके आ रहा था, इतना मालूम था. वहां का एनालिसिस किया, वहां का लोगों का इन्फ्लुएंस किया, तो ये पता चल रहा था कि प्रोडक्टिविटी उनके ऑब्जर्वेशन में, क्योंकि उनको पानी अवेलेबल नहीं हो रहा था, दैट इज फर्स्ट प्लेस. सो दे सेड कि हमारे पास तो और कोई ऑप्शन नहीं था, बट हमको ये यूज करना पड़ा. फिर उन्होंने बताया कि हमारा तो प्रोडक्टिविटी कम होता जा रहा है. जहां पे डोमेस्टिक सीवेज, ट्रीटेड डोमेस्टिक सीवेज, दैट मीन्स द मोस्ट, जस्ट टू टेल लिटिल मोर, once we are using the non-treated domestic sewage, the problem of the the soil, the topsoil layer getting completely impervious. It's like, I should not use the word impervious, but the pores of the soil gets clogged. So that creates the soil sickness. So if that is avoided and we are putting a nourished water, then it improves the productivity of the soil. But that was, so places where the treatment was not done, in that the observation was that the productivity was going down. Now it could be because of untreated, and it could also be because of
positive,
the
okay.
Yes.
Okay, now we want to say sigma bx. Sorry.
Oh.
Sigma bx is bending about which axis?
I don't know, somebody else is
Dear participants, please mute your mic. Sir, please carry on.
Yeah, so in that observation was like whether the productivity was reduced because of the sewage being untreated, or dominantly because of the industrial waste and the heavy metals and other type of contamination. But the observation was that both of these things might have actually led to the reduction in the agricultural productivity. What dominates is still a question. I mean, we have no demarcated answer for that.
Thank you, sir. Thank you. I think Any more questions from participants? Okay. Okay, sir, thank you very much for your very deep and informative and innovative presentation, highlighting a very new topic and the means one of the, I can say, the major required societal issue also.
Yes, it's a very, because all said and done, even if I say a reduction, that it may agricultural productivity, I mean agriculture sector might not be contributing that high to our GDP, but fact remains that 15% contribution GDP ka to ho hi raha hai, and around 45% agricultural sector is generating the employment. So we have no other option but to actually focus. So that's why, Manish, it's like sustainable development. जब मैं बात कर रहा था आपके टॉपिक से, so I really was convinced कि ये मुझे बोलना चाहिए कि
नहीं sir, really it's a very excellent topic, and really I think this topic will also now give a good vision, or it will open the eyes of many other sectors or people that yes, we should work in this direction and contribute something, sir.
Definitely, it's like new knowledge, scientific interventions. I think universities have to produce, and then only, and that's why, as I think one of the like Shayad Poonam ya Alpa, that policy makers that. So once, I was asked by the this BRNS, Board of Research in Nuclear Sciences, that have your outputs so that we can talk to Ahmedabad Municipal Corporation along with the other the competent authorities to actually take a decision that what should be the you know, the way the agricultural productivity has to be improved. So we have not reached to that stage, but yes, we would like that in maybe in next 1 year or so, at least our fundamental outputs we would be, I mean results we would be having, which might be helping the policy makers to take some better decisions.
Definitely, sir. Definitely. So, sir, thank you very much once again. On behalf of Applied Mechanics Department, LD College of Engineering, sir, we are wholehearted thankful to you that you accepted our invitation and have agreed and have delivered a wonderful lecture on this topic, sir. So, thank you once again, sir. Thank you very much.
Thank you so much, and goodbye, and all the best for the participants. Thank you all.
Thank you, sir. Thank you. Thank you very much. So, dear participants, now we will be moving ahead with our fourth presentation, that is on landslide monitoring and early warning by Dr. Kala Venkata Uday, who is from